This is Mr. Wise coming to you from my treadmill today because today's lesson is about energy. Hopefully I can both teach this lesson and not fall off at the same time. So energy is the ability to do work. Work is when we use a force. Remember, we measure force in newtons. We use a force to move an object over a given amount of distance, and we measure that distance in meters. So when we multiply force times distance, we get a Newton meter. All right, some of these terms should be familiar to what we've done before. Keep in mind, a Newton is a kilogram meter per second squared. When we multiply a kilogram meter per second squared times a meter, we get a kilogram meter squared per second squared. Another way to say that is a Newton meter. And a Newton meter can be complicated as well. And so another way to say that is a joule. So work or energy is measured in Newton meters, which is a little more intuitive for what we've been talking about so far, but the unit of energy is in joules. Now, as I've said before, energy is expressed in units of joules, calculated as force times distance. And so when we move an object over a given amount of energy, so I'm right now walking on this treadmill, I'm using a force to move myself a certain amount of distance. Though if you've ever worked out on a treadmill, it might seem like you're doing better than you do in real life. And part of that is like my mass right here is pretty much staying at the same place. If I slow down, I kind of go back on the track a little bit, and then I end up falling off the end. But I'm not really propelling my mass forward as much. And so, when I am running on the treadmill as opposed to when I go out on the road and I run on the road, I always run faster on the treadmill than I do on the road. And that's simply because I'm not propelling my entire amount of mass forward. It's just something we have here. Now, there are energy. We classify energy into two broad categories of energy: kinetic energy and potential energy. Whenever you see that phrase kinetic, as we've talked about this year, kinetic means motion. So kinetic energy is tied to motion, like the motion that I have right now on my treadmill. That is kinetic energy. So when something is moving, it has kinetic energy. When something is still, it doesn't have any kinetic energy. Because kinetic energy, in order to calculate its kinetic energy, we multiply it by its velocity at some point in time. And if the velocity is zero, then it's not going to have any kinetic energy. So in order to determine, it's actually mass times velocity squared. So when we determine kinetic energy, the object must be in motion. If it's not moving, then it has no kinetic energy. Potential energy can be expressed in a variety of different formats, but essentially potential energy is object that is stored. Now, what is it stored from? It can be stored from a variety of sources. It can be stored by its position. For example, you see the picture there of the roller coaster. When the roller coaster car is at the top of the roller coaster, there was work done to it to get there, okay? And that work done to it is now stored in it based upon its position. The same thing with water that is in a lake behind a dam. As the water is allowed to, say, pass over that dam, perhaps to turn a turbine to produce electrical energy, that water has potential energy because of its position, because of its high elevation. And so gravitational potential energy is based on its raised position. A book that is on a bookshelf that would fall down, falls down because of its raised potential energy. Whereas if it was laying on the floor and it shakes and it moves, whatever, it's not going to fall anywhere because it doesn't have any potential energy. Another type of potential energy is what we call elastic potential energy. And you see the picture of the slingshot right there. When you pull back on that slingshot, you are doing work. And as you hold that slingshot pulled back or hold it taut, there is energy that is stored in that string. stretched elastic material of the slingshot. It says there on the notes that it's known as strain energy. But we can take a spring, and some springs work by we stretch the spring and they want to come back. Other springs, you compress them and they want to open back up. It just depends upon the type of spring and what it's being used for. But a spring would have elastic potential energy. Think of a bow with a bow and arrow. We pull back on that bow and arrow in order to get that potential energy. Now, once we understand kinetic energy and we understand potential energy and the two different parts of that, we understand that when an object is in motion, it is constantly going between maximum potential energy and maximum kinetic energy and converting it somewhere in between. If we took a ball and we were to hold that ball up and we were to drop that ball, as we're holding it up and the ball is not moving, it wouldn't have any kinetic energy, but it would have some potential energy based upon its raised position. As you let go, due to gravity, it is going to fall down towards the earth, and the longer it falls, the less potential energy it has, but also the longer it falls, the faster it's going, the more kinetic energy it has. When that ball hits the ground, that energy is going to transfer, and the ball itself is going to compress. And so now it's going to have elastic potential energy, and it's going to push against the floor just as the floor is pushing against it. Newton's third law, equal and opposite reaction, and that's going to propel it back upwards. Of course, it doesn't go as high as what it normally would because of friction, because some of that energy is given up in heat. That's what friction does to that environment. But in any moving object, moving scenario, whether that be a vehicle such as a roller coaster car or a bicycle or a scooter or a skateboard or a car, we always have to concern ourselves with the conversion of the kinetic energy and potential energy to kinetic energy.